Good evening, everyone, and welcome. My name is Ingrid Schwarzkopf. I'm a recruitment officer here at the Faculty of Applied Science and Engineering at the University of Toronto. Thank you for tuning in this evening. Tonight we're going to be talking about the chemical engineering program here at the University of Toronto. Just bear in mind, tonight we won't be addressing any admissions questions on screen. However, if you do have any admissions questions, my colleague Steve on the chat will be happy to assist you and give you our email contact information so you can connect with us offline. So today with us we have Professor Yip and Neha, and so before we get started, I just also want to welcome all of our audiences. Some of you may be prospective applicants, some of you are applicants currently, some of you might be admitted already, and we want to thank you on behalf of the faculty for joining us. U of T is known for its world-renowned faculty for leading-edge research and discovery. So regardless of the program that you choose, you will have access to U of T's top-ranked professors like Professor Yip, and as well as the curriculum that is constantly evolving, and we really will touch on that tonight, on some of the unique things that the program offers, and how it's an interdisciplinary program, and how you can tailor your degree based on academic options, minors, certificates. So we're going to touch on all those key components specifically for the chemical engineering program. But I'm sure everyone is anxious to hear from our guests tonight, so I'm going to turn it over to Professor Yip and Neha to introduce themselves and give us a little bit of a background of who they are. So, Professor Yip.
So, good evening. I'm Professor Yip. I'm a professor, obviously, in chemical engineering and applied chemistry, but actually I'm also appointed to the Institute of Biomaterials and Biomedical Engineering, and I'm actually the director of that institute. So, for those who are interested, we're going to talk a little bit later about the biomedical engineering opportunities in ChemEng. I'm happy to present some of that. A little bit of history. I'm actually a graduate of this department, and I've actually circled back a few years later to become a faculty member here, so I can give you that perspective as well. So I'm happy to be here tonight.
Hi everyone, my name is Neha and I'm a fourth year chemical engineering student. I'm also enrolled in the engineering business minor, and through my undergraduate thesis project I got to explore financial technology a little bit. So that's a quick background on me.
Great, so it looks like we're going to have lots of things to talk about, that's for sure. And to start the evening off, and I'm sure many of our guests are thinking this, and I tried to represent chemical engineering as a recruiter to the best of my abilities, but I can't do justice and say it the way that you two may have. So why don't we start off by Professor Yip kind of introducing us to what chemical engineering is, and perhaps you did mention the biomedical option. Many students, when I talk to on the road, ask, well, do you have a biomedical option? And I'm understanding the best route is through chemical, so maybe you could touch on that as well.
I was going to say, of course it's through chemical. That's why we're here today. So I guess, for me, chemical engineering really is, it's the way we sell is always the application of chemical processes, chemical reactions in an engineering context, applying chemistry to pretty much anything that has to do with everyday life. The way I like to portray it is actually it's one of the, I would argue, the broadest discipline. Almost anything that you do in life has chemistry underpinning it. An interesting perspective, you may think chemical engineering, you start thinking big chemical plants and all that kind of stuff, and the classic picture. And I push it back to you and say, actually, an interesting way to model is like a cell in your body is exactly the same thing as a chemical plant. Lots of inputs and lots of outputs. And the models that we use for chemical plants, we use in biology as well, in biochemistry. And as Neha was intimating a little bit that she's in the financial industry, I'm going to steal her thunder a little bit and say that the banking industry and financial industry also deals with that same kind of inputs and outputs. And it's something that chemical engineers are very used to dealing with. So it's an exciting field. Lots of applications, lots of opportunities. Did you want me to talk about biomed as well?
Yeah, that'd be great if you could touch on the biomed.
So as you indicated, biomedical engineering is we don't have actually a department, but we actually have a very interesting model, which is the minor. I'm sorry you're not in the minor, but I'll give you that pass. The minor is actually an opportunity you can join it in third year. It's a very exciting opportunity to get engaged in biomedical engineering. Chemical engineering is arguably at the core of biomedical engineering, with a lot of biomaterials work, a lot of chemical processes and things like that. And it's a terrific option. It's grown over the past 3 years to almost the second or third largest minor option within engineering right now. And I'll also add that bioengineering, for those who are interested in the biomedical component, is also actually the oldest. I think it's the original minor in engineering, and that's for those who are also interested in the interface between engineering and biology. Again, largely centered in chemical engineering. Came out of that department. So lots of
Great.
ways.
And now, would you say a lot of the components, nowadays you see new engineering programs where they're called bio and medical engineering programs. Now, some of the courses those students would have access to, are they courses that our students would have access to as well?
You're talking about other universities.
Yeah.
Yeah, so actually it's an very interesting perspective you bring to that. So biomedical engineering is an incredibly diverse field, and it includes everything from people doing electrical through to chemical. And so the minor option at UT is, we think, probably the best way to do it, because a student who's very interested in the chemistry behind biomedical engineering can come in through the chemical engineering stream or direction and department and do biomedical engineering. They will be interacting with students who are coming in from the electrical engineering stream doing biomedical engineering, and they're going to work in collaborative teams in their capstone projects. This allows a student to actually have a core training in their core discipline with biomedical on top. If you look at other schools, they tend to skew the discipline to a particular area. So some schools will be very electrical engineering focused, others will be very chemical focused. And so if your interests don't align with that, the program may not work well for you. And for us, very flexible.
Which really speaks to our program's flexibility and options that students have, and I'm sure Neha can speak to that, right?
Yeah, absolutely. One of the wonderful things about chemical engineering in particular is that all of the minor programs that are offered within U of T Engineering work incredibly well with our schedules. So for example, I mentioned earlier that I'm in the engineering business minor, whereas I have friends who are focusing on sustainable energy. I have friends who are in the biomedical minor or the bioengineering minor.
Good for that. Yeah.
So there's definitely a lot of opportunity to explore what it is that you as an individual like. And even a step further is in the chemical engineering program, in our first 2 core years, we get enough exposure to actually try and figure out which path we want to take. And I think that's something really special as well.
And maybe, while we're at this, maybe you can tell us a little bit about the opportunities you've had over the few years. We always want to learn more about what opportunities do chemical engineering students have. So what are some of the opportunities that you feel like you've gained from the program?
That's a great question. So opportunities more in like a professional sense, or
it could be curriculum, extracurricular, curriculum, any opportunities, courses.
Okay, yeah, great. So I'll start with the extracurricular stuff. So I'm actually currently the chair of our, what we call a discipline club, kind of like a student council for undergraduate chemical engineering students. And that's been fantastic. Our community is very tight-knit. And it's a great way to get involved. I've also had the opportunity to be a part of consulting clubs, clubs that focus in on the mining and metallurgical industry, also the University of Toronto Energy Fair. So there are endless opportunities on that front, and it's very easy to get involved, even in first and second year. In terms of some of the more professional opportunities, again, coming back to chemical engineers being everywhere. So, for example, I personally was able to start my own company after second year, making soaps, which I could do because I had a chemical background, which was fantastic. And then from there, I got to also explore the financial industry a little bit. So now I'm looking at going into consulting. I have friends who have done internships all across the board, from oil and gas companies to pharmaceutical companies, again to consulting companies. And professors are really, there to help you get those opportunities, whether it's connecting you with vendors when you're starting your own company, or helping you find the right kinds of jobs for what you're interested in.
Now, I want to hear more about this. So,
absolutely.
So is this, I'm aware, the U of T engineering curriculum, we start design off right away in first year.
Yeah.
Now, was that something that spearheaded in your first year? I'm just kind of interested. Maybe you could tell us a little bit about the design opportunity component, I guess.
Absolutely. So, I'd say that the lessons I learned in first year engineering strategies and practice, which is the, core design course, definitely helped me kind of get in the mindset to launch that company and go through the motions of really solving the problem.
Absolutely.
And I'd say that was followed up definitely by some of the courses I took in second year, mostly the practical lab courses that we have in second year, as well as the engineering economics courses, which really kind of opened my eyes to the business side as well. So yeah, I've definitely learned a lot through school that helped me launch that initiative.
That's great. And what's your company called?
Summer Soaps Company.
Summer Soap. So everyone
Summer.
should be Googling that right now.
Definitely.
And Professor Yip, do you have any other things to add to what some of your students have been doing in their projects or design or in the department? What capstone projects students are pursuing?
There's lots of great opportunities. Actually, one thing I wanted to add is that,
Mhm.
that students can actually, who are conflicted between options, could actually take take more than one minor. So you can register into taking the financial minor and the biomedical engineering minor if you're interested as well. But I think what's key is that within ChemEng you have obviously these early design courses as well, but then you've got fourth year thesis, and you actually have plant design mixed in there as well.
Okay.
So you've got the opportunity to you went through that.
Oh, yes.
So and I went through that as well when I went through undergrad, so I know exactly what you're going through. But that's an awesome opportunity, first off, to bring your group together and take your entire 3.5 years of curriculum and roll out a chemical plant design. At the same time, you can run your individual thesis project, right? At the same time on top of that. So students can do all this, and what's nice is that the department has such a broad mix of faculty in terms of research areas some are classic chemical engineering, some are very biomedical. I'm a biophysics kind of person, so our group does a lot of instrumentation builds. And so there are other groups doing modeling, and so students can easily find projects which fit exactly what they're interested in and see how well it fits with their career plans actually are.
So there's really a lot of options for our students. So you don't really have to come into the chemical engineering program really knowing what area of focus you want to really stick to. And I'm sure you probably didn't know in first year you were going to go down this route, right?
No,
Did you
no.
start in chemical in first year?
I actually started in track 1.
Track 1, okay, great.
Engineering, and then I picked chemical pretty quickly, I'd say.
Yeah.
I think I knew sometime early second semester. But in terms of, I guess specializing even within ChemEng in terms of picking a minor, I don't think I figured that out until third year.
Which is okay, right?
And it was okay. It was totally fine.
And that's the great thing.
Yeah.
It's the flexibility and the options that the university offers is really great. And
Exactly.
there's also so many great things that the program offers in addition to that. And maybe we could touch a little bit on some of the research that have come out of that are happening, and some of the work your students are doing in the summer. Or Neha, have you done any research in the summer?
Not in the summer. I
Okay.
actually am doing an undergraduate thesis project right now, though.
Oh, great!
Um,
Maybe you could tell us a little about that.
I can tell you a little
Yeah.
bit about that. So I'm actually doing it in the area of financial technology.
Okay.
And my project involved me working with a large Canadian bank to help them pinpoint different areas that they could explore.
Yep.
Fortunately, I can't really say much more than that because I signed an NDA.
No worries, no worries.
It's a really exciting project, and I learned a lot firsthand. Professor Yip can definitely talk more about research though than I can.
Yeah, for my own students, over the years, we've had students do everything from inventing new technologies in the lab to working with colleagues to doing cell imaging and measuring properties and things like that of different materials and using different instrumentation. I think that's the kind of the classic academic lab experience for the summer. I think what's important to realize is that there's those research opportunities that are outside, working for companies over the summer, or even taking part in some of these research opportunities that are actually overseas, right, or in companies that are elsewhere. So Neha touched at it in the context of some of these opportunities, but we've certainly had PEY students go abroad, right, doing sustainable energy projects. They've gone to Scotland, they've gone to Australia, they've gone to Singapore, all doing projects, some of them on short 4-month projects, right, where they'll get course credit for it, some of them on longer, 12 to 18-month PEY opportunities. And I think they're great. They take you, out of the academic environment. I think hanging out on campus for the whole 4 years is probably not the best plan. I went through undergrad without ever spending any time in an academic research lab other than thesis, right? All my positions were actually, one was with the Coast Guard, one was with Imperial, one was with ESO. Right?
And you still end up in academia.
And you still end up in academia, right? So, exactly, right? And so it's not so much about having to do the research opportunities, which are great, but it's looking outside as well. So there's lots of things out there, and quite diverse.
And for our audiences, at the University of Toronto's engineering program, PEY is our professional experience year, so it's an optional internship that students take after they've completed a year 3, and then they can work whether it's from 12 months to 16 months. So it's a really great opportunity, as Professor Yip was saying, to really gain some experience. It is paid, average salary is $50,000, so it's an opportunity to make some money. Can you give some specific company examples where some of your students have went, if you're aware of?
Yeah, so did a little digging. You can contribute some of them, but we've had students go to the classic chemical companies,
Yep.
right? So Suncor, TransCanada Pipelines, Husky, Imperial, and so on. But you also had students, as Neo was indicating, Deloitte, Hatch, Moneris, for opportunities in kind of that consulting field, in the fintech field. We've had students that in past years have gone to work for BMW, which would be a pretty amazing position to be working in for the summer or for a PY opportunity. So I think these are all areas. They're outside maybe the classic chemical sphere, but it's really taking advantage of the students' skill set. Students have gone to Ontario Power Generation, they've gone to Sanofi, they've gone to all the full breadth, really, to reflect the capabilities and the skills that we give your students, right? They learn. Yeah.
And did you partake in a PY?
No, so I actually did not go on PUI. Many of my friends did, though.
Yeah. So I mean, and that's a great thing too, right? I'm sure maybe in your first year you thought, yes, I'm definitely going to do a PY.
Exactly.
But the nice thing about it is that if you change your mind, it's okay.
It's okay.
Because you're not locked into it, right?
Exactly.
So you choose that later on, which is a really, really nice kind of
Absolutely.
reassurance to have as well. Now, where would you say your graduates go typically? Are they more geared towards going into research or industry, or is it kind of a mix of everything?
So that's actually a really interesting question, because there's certainly a certain percentage of students who will go on to graduate school.
Yeah.
Right. They're interested in doing a master's or a PhD depending on their focus. Some will go directly into industry. Some will run startups, right, which is an awesome output from an entrepreneurial perspective. A lot will go directly into industry. There's a large and growing biotech thing on near campus, literally kitty corner to UT campus, which takes up a lot of our graduate students as well in that kind of area. So the opportunities are basically, some of my friends from undergrad ended up working for, it's a little odd, in arson investment. That's an application of chemical engineering, but